We just had it in the table.
Interior angle, miss.
Sum of interior angles of a quadrilateral. Look back in your
360.
table. 360 degrees. So because we are going to be focusing in more details on quadrilaterals now, I want you to just write that information again under the heading. So under the subheading quadrilateral, I just want you to write these statements again, that the quadrilateral has 4 sides and the sum of the interior angles is 360 degrees. I can't make a little zero. 360 degrees. All right. All right. So when we think of quadrilaterals now, when we think of quadrilaterals, we're thinking of 4-sided figures. So name me some 4-sided figures that you know.
Height.
One from each person. Kamisha, somebody. Who was it for? Who is that?
Height.
All right. Kamisha said kite. Somebody else. Rhombus. Another one. Square. Another one. Huh?
Diamond.
I don't know the name, so.
No, miss, me know
So,
sometimes. Me no know for true.
all right. So we hear kite. We hear rhombus, we hear what again? Square. Mm-hmm. Rectangle. Yeah, the most common one. Nobody never say it. Rectangle. One more. One more. All right, you've done well. Let us move on. The others will come up. So quadrilateral. So it doesn't matter what the name of the quadrilateral is. The sum of the interior angles remain the same, 360 degrees. But let us look now at some of them specifically, because we need to know the characteristics of these quadrilaterals, because if we are asked to construct them, for example, or to draw them, or if if they are referred to in a question, you need to understand exactly what they're talking about. So some of them can be put together under one main heading. So let us make a note of this for me. Make a note of this for me. There are 3 main types of quadrilaterals. I won't be able to write everything on the whiteboard because it's kind of a lot to write. But make a note from everybody. 3 main types of quadrilateral.
Mm-hmm.
All right. All right. Just came back in, so let me write it so she can know where we are. 3 main types: TYPES. So I'm going to put them under a certain heading. If something on the whiteboard that is not clear, just let me know, because I'm just writing on this whiteboard. 3 main types of quadrilateral. All right. I'm going to list them and then we go in more details. 1, parallelogram. Parallelogram, that's 1. 2, trapezium. And 3, kite. Parallelogram, trapezium, kite. Everybody can spell parallelogram, right?
No, miss. You can't spell.
I don't believe you. Parallelo.
Gram.
Yeah, gram. RAM.
It's all trapezium spelled.
Trapezium.
I'm bright. How kite spell no, miss?
Of course you are. Go away. I'm not going to spell no kite for you. All right. So parallelogram, trapezium, and kite. All right. So everybody know what a parallelogram is, right? You know what a parallelogram looks like?
No, miss.
But here, let's write down the definition, because now under parallelogram, we have different names or different types, right? Different shapes that we put under this one general heading of parallelogram. So write for me. Parallelogram is a quadrilateral. So on the parallelogram, you are writing a quadrilateral having one pair of opposite sides, parallel and equal. One pair of opposite sides, parallel and equal. Let's go from the top again. We're talking about quadrilaterals, right? We're talking about quadrilaterals. And what's a quadrilateral?
Quadrilateral have 4 sides.
A four-sided figure, a four-sided shape. What's the sum of the interior angles?
360 degrees.
360 degrees. All right. And what are the three main types of quadrilaterals that we are going to discuss?
Parallel, parallelogram, trapezium, and kite.
All right. Other people go and sleep? So three main types of quadrilateral: parallelogram, trapezium, kite. So let us look at the parallelograms now in more detail. So we said a parallelogram has one pair of opposite sides, parallel and equal. That is equal in length. Good. So here we go with the types of parallelograms. First type you're going to make a note of for me now is the one that is the most common one in everyday life. Almost everywhere you look, you see rectangle, don't it? The most common parallelogram, I would say, is a rectangle. So put A in bracket for me and put rectangle. 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 Don't like how this look. RECTANGLE. Rectangle. And as I say, we see rectangle almost everywhere. But there are some other things about rectangle you need to know. Sketch a rectangle for me quickly. Sketch a rectangle. Let's sketch a rectangle as we talk about it. Sketch a rectangle. Just sketch it. Just use a straight edge. You know that a ruler, as a rectangle, you learn from primary school, rectangle have 2 long sides and 2 short sides. But it's more than that. So yes, opposite sides are the same length. Come on, stuff. Line up back. Right. But what is important too is that the corners are all right angles. The corners, when you sketch a rectangle, put that little box in the corners, because that is what makes that's what makes a rectangle really a rectangle. It's not the 2 long side and 2 short side, because other quadrilaterals have 2 long side and 2 short side as well. So what makes a rectangle is the fact that the corners are right angle
And 90 times 4 will give us 360. Let's see.
Exactly, very good. So each angle is a right angle, and the diagonals, there's something also about the diagonals. What do I mean by diagonals? What are diagonals? Diagonals would be the lines that are drawn from one corner to the other. So let's put in a diagonal from the top here, going across down to the bottom. That's one diagonal. And a diagonal coming from the other corner to this one.
Please, you can
All
repeat that.
right.
Diagonal.
For the rectangle, it has equal diagonals.
Oh.
Equal diagonals. Yes. So if you were to draw a rectangle accurately, put your ruler across from one corner to the other corner, and put the ruler from the other corner to the opposite corner, you'll find that those distances, that's what we call the diagonal. So the rectangle has two diagonals, and the length of the diagonals are the same. All right? It doesn't happen for every quadrilateral, but this is it for the rectangle. So what makes a rectangle a rectangle? All the angles are right angles, and the two diagonals are equal. In fact, we can put a mark. We can put some marks on the shape, on the diagonals, to show that they are equal. Right? So I don't like that yellow. That is not bright enough. Let me use a different color. Probably I can. Pardon? Is it red? All right. So I'm just putting the mark there to show, right? The diagonals are equal. Yeah. So equal diagonals, and each angle is a right angle. All right. So that's one. There are some more things about parallelogram we're going to look at in general, but let's look at the three types of parallelogram. So the first one is a rectangle. The next parallelogram is a square. Let me put it over this side for the sake of space. Let me put it over here. Square. Yeah, SQU. That is too big. It's not going to hold there. UARE. It's a square. SQUARE. A square. Now, what makes a square a square? Let us sketch the square. Let us sketch a square. All right, so this is our square. Sketching a square. And what do we know about a square? All sides are equal. All the sides are the same length. What about the angles? Same. The angles are all right angles too. The angles are all right angles. Are the opposite sides equal? Yeah, of course they're equal. All sides are equal. Are the diagonals equal? Yeah. Are the diagonals equal? Everything equal. All right. So guess what happened now? What do you think is the connection now between a square and a rectangle?
Connection. There are four triangles.
Four right angles, four equal sides. The diagonals also, we can put in the diagonals as well. Let's put in the diagonals. Let's put in the diagonals.
Oh, is that it? Add up to 360?
Add to 360 just the same. Yes. Add to 360 just the same. I like how this diagonal look. I'm going to erase this one. This diagonal tooling. All right. It's a little better. All right. So guess what happened now? A square can be regarded as a rectangle. Yeah. It has all the properties of the rectangle except what?
Equal sides.
Ah, awesome. So a square is a rectangle which has 4 equal sides. Write that down. A square, write it down for me. A square is a rectangle which has 4 equal sides.
A square in a rectangle?
A square is. A square is a rectangle. Which has 4 equal sides. Square is a rectangle which has 4 equal sides. You have that? I'm in a class. Yeah. All right, can Vado read the statement you have about square for me? Vado? Not there? David, what did you write down about square? Awesome. And that's what everybody needs to have. So we need to know that the square and the rectangle have basically the same properties, except that the square has 4 equal sides. All right. And we can also put the mark on the diagonals as well to show that they are equal in length. We can also put these marks on the diagonals to show that they are equal. All right. And the last type of quadrilateral we want to look at now is what we call the rhombus. R-H-O-M-B-U-S. So let's call this one C. Let's call this one C. I might have to use a different whiteboard again. R-H-O-M-B-U-S. I'm trying to keep as much as possible on the whiteboard because I realize that people are coming in and out. It could be that the internet not keeping up. R-H-O-M-B-U-S. Rhombus. So Kamisha, when Kamisha said diamond, I think this is what you were thinking about, Kamisha. When you said diamond. Yes, I think this is what you were probably thinking about. Let me see if I can sketch the rhombus now. You might want to sketch it in a vertical position. We could sketch it in a vertical position like this. We'll sketch it in a vertical position like this. Why is this thing coming like that now? Pressing too hard on this board. All right. Pressing too hard on this. I don't want it to come out like that. That. Something looking like this. Rhombus. Or if we go it sideways, we can go looking like this. This. Why my lines coming out squiggly now? I don't know, squiggly line. I want straight line. Come on. I didn't change anything on the screen. All right, this is the idea. So use your straight edge on your pencil and sketch something looking like this. That will be the rhombus. use a different color to put in the diagonals. I'm going to use a different color to put in the diagonals again. Let me go back to the green. So the diagonals now. All right, so first of all, for the rhombus, let us describe the rhombus. Oh, we're gonna have to wrap up now. So let's just wrap up with the rhombus. So underneath rhombus, write for me 4 equal sides. So the rhombus has 4 equal sides. Let me just put a mark on all the sides. 4 equal sides. Rhombus, 4 equal sides. Diagonals bisect at right angles. So 2 points under the rhombus. 1, 4 equal sides. Second point, diagonals bisect at right angles. What do we mean by diagonal?
Angle that cut.
A line that goes across from one corner in the polygon to another corner. So here's one diagonal. Look at the whiteboard. Here's one diagonal. And here is the other diagonal. All right. Yes, so those are the 2 diagonals from one corner to the other.
You repeat that. Thank you.
The facts about the rhombus. Point
No.
number 1.
No.
Pardon me? Pardon me?
No, it's from 4 equal sides.
Yes, so I'm going to repeat that. So underneath rhombus, you have 2 main points. 1, the rhombus has 4 equal sides. S-I-D-E-S. 4 equal sides. And second, diagonals. Diagonals, D-I-A-G-O-N-A-L-S, diagonals bisect. Diagonals bisect at right angles. So where I have the diagonals meeting like this, where I have them meeting here, it's all right angles all around. Right in this little section here is right angles all around. The diagonals bisect at right angles. Okay, so right away we have the 4 lines meeting in the center there, right angles. They bisect at right angles. So let us recap the types of parallelograms. We have rectangle that has equal diagonals and each angle is a right angle. We have the square, and the square has all the properties of the rectangle except for the fact that the 4 sides are equal. That is why we can say that a square is a special type of rectangle. A square is a special type of rectangle. All right. All the corners are also right angle. The diagonals bisect each other. Okay. And the diagonals are equal. The rhombus has 4 equal sides also. The difference with the diagonals now for the rhombus is that the diagonals meet at right angles. For the rhombus, the diagonals, they bisect. So they cut each other, divide each other in 2, and they meet at right angles. That's for the rhombus. For the rhombus, what do you want me to repeat? What should I repeat? Everything for the rhombus? All right. The rhombus has 4 equal sides. S-I-D-E-S. 4 equal sides. That's point number 1. Point number 2, diagonals bisect at right angles. Diagonals bisect at right angles. And here you have the sketch, the one down the bottom here. So the red mark in the center there is showing that the diagonals meet at right angles. And what do we mean by bisect? When we say they bisect each other, what does that mean? Cross each other, not only cross each other in a special way. They cut they cut each other, but in what proportion? At right angles and in equal parts. Yes. When you bisect something in relation to our mathematical term now and this topic, bisect, when you bisect an angle, you divide the angle in two equal parts. You bisect a line, you divide it in two equal parts. The diagonals bisect each other in the rhombus here. The diagonals bisect at right angle. So they meet at right angle and they cut each other in two equal parts. Okay, doc? All right. So there are more things about the parallelogram and the other parallelograms we're going to have to look at in more details. And then we continue on this. So the next 6 weekly text you're going to be getting next week is going to include this topic that we are doing this week. All right. So I'm going to, pardon me?
Monday.
I don't think it's going to be Monday. We may not. I want us to wrap up this properly. If we have to look at exterior angles, we have to look at various sort of word questions, related to angles and polygon. And sometimes the polygon is tied in with the construction and so on. So we have to get to that level. Okay, your questions must be CSEC type questions. Not just little easy thing, but CSEC type. Not anything you can't manage. I'll find questions that are in keeping with the objectives that we would have covered. But I want you to get accustomed to looking at how the questions are set. And I would want to do examples of that in class before I put it on the test. All right? All right. So I'm going to have to wrap up here so you can transition to your next class. So I hope we'll be able to get back face-to-face by tomorrow. All right. All right. Enjoy the rest of your afternoon.